Hello and welcome to another Orange Coast College mathematics video. In this video, we want to learn how to factor a quadratic trinomial of the form ax squared plus bx plus c, but specifically when a is not 1. The case when a is actually 1 we covered in the last video, factoring quadratic trinomials part 1. So I will assume that you know how to do that. All right, well, how do we factor something like this? Factoring ax squared plus bx plus c when a is not 1 is a little more complicated than the case when a is 1, but it is similar. Now, the first step, always factor out the greatest common factor if you can. Okay. The second thing is we're going to look for two numbers whose product is not c, but a times c. So we're going to multiply the coefficient of x squared by c, and we're looking for two numbers whose product is a times c, but again, whose sum is b, the coefficient of x. And once we find those two numbers, we're going to split up the bx term. I want to write it as something x plus something else times x, where these two coefficients are the two numbers you found in step 2. So what you're going to do, though, is you're going to write bx as, again, something times x plus something else times x. And again, in those two blanks, you're going to put the numbers you found in step 2. Now, you should have a 4-term polynomial, basically ax squared plus blank x plus c. And you factor that new 4-term polynomial by grouping. When you're done, check your work. Let's do an example. So here we have a quadratic trinomial, okay, 4x squared plus 12x plus 5. So the a is 4, the b is 12, and the c is 5. So that means that a times c is 4 times 5, which is 20, and b is 12. So we need to find two numbers whose product is 20, a times c, and whose sum is 12. Now, in general, it may not be possible to find two such numbers. But in this instance, 10 and 2 will work, right? 10 times 2 is 20, 10 plus 2 is 12. So what we do is we're going to rewrite our polynomial a little bit differently. I'm going to split up 12x into a sum of 10x and 2x. So it's going to be 10x plus 2x, and then write the plus 5 here. And now we have two pairs of terms. I'm going to factor this by grouping, which means from each pair of terms, factor out the GCF. So from the first two terms, right, we have a 4x squared plus 10x. The GCF is going to be 2x. So if you factor out the 2x, you have left over 2x plus 5. Now from the second two terms, the GCF is just 1. So I'm going to write a 1 here. I'm going to write this explicitly. So the second two terms becomes 1 times 2x plus 5. And now you have two terms, term 1, term 2, with a common factor of 2x plus 5. So factor out the common factor, 2x plus 5. You're left with 2x plus 5. And then left over, you have 2x plus 1. And that's it. You can, of course, distribute those two polynomials and see, do you end up where you started? Here again, we have a more complicated example. Notice we have two variables now, c and d, but the technique remains the same. So I'm just going to treat the c as if it were my x squared. Okay, so we have our a is 8, our b is negative 14, and our c is 3. So that's if it was like ax squared plus bx plus c. So a times c in this case is 24, and b is negative 14. Now, we have to just simply look at this and say what two numbers multiply together to give me 24 and add up to negative 14. Well, the answer is going to be negative 12 and negative 2, right? The product will be positive 24, and their sum will be negative 14. So we split negative 14 CD into two terms. So this will be 8c squared minus the first one I said was 12 CD, and the other one was -2, so -2 and -12. Okay, so we break up -14 CD into -12 CD minus 2 CD. And then we have plus 3D squared over here. You might ask, does the order in which I wrote these two terms matter? And the answer is actually no, does not matter at all. If I had written it -2 CD and -12 CD here, wouldn't change the problem. All right, so now we factor by grouping. So we have two pairs of terms. From the first term, we want to factor out the greatest common factor, which in this case is going to be 4C. We can factor out 4C, and then from the first term, we'll have 2C left over. And from the second term, we will have -3D left over. Now, from the second two terms, the GCF is going to be simply D. So I'm actually going to factor out -D here so that the terms match up. Factor out -D, and then what you'll have left over will be positive 2C, and you will have minus 3D. Okay, and now we have two terms. Simply factor the common factor 2C minus 3D from both terms. So we factor out the 2C minus 3D, and then left over we will have 4C minus D. You can multiply this back out, and if you do that, you will end up where you started. Okay, here we have one last example. So here we notice, if you look at this trinomial, we have common factors amongst the three terms. In fact, each term is divisible by 6, and they all have a common factor of y. So we start by factoring out that greatest common factor of 6y. And then left over, we will have 8y squared plus 2y minus 3. So now we have a quadratic trinomial. Okay, so in this case, a is 8, b is 2, and c is -3, which means AC is -24, okay, and b is 2. So we're looking for two numbers whose product is -24 and whose sum is b. So the two numbers that will fit those requirements would be positive 6 and -4. Positive 6 times -4 is -24. Positive 6 plus -4 is 2. So we now will split up that 2y as a sum of 6y and -4y. So we have 6y times 8y squared plus 6y minus 4y minus 3. And again, the order that I wrote these two does not matter. You'll still be able to factor it by grouping regardless. So now we have two pairs of terms, and we want to factor the GCF from each pair. So what we have is we have 6y still. Just keep copying that down. From the first pair, the greatest common factor is 2y. And once we factor out 2y, we will have 4y plus 3 left over. Now, from the second two terms that I've underlined in blue, the GCF of those is 1, but we want to factor out a -1 so that we have that matching 4y plus 3. So we factor out a -1, and that leaves us with 4y plus 3. And then inside these brackets, we have a common factor in our two terms here. We have a common factor of 4y plus 3, so simply factor that out. So we will have 6y times 4y plus 3. And then left over, once we've factored out 4y plus 3 from each term, we will have 2y minus 1. And that's it. Feel free to check the work and make sure you get back to where you started. And there you have factoring quadratic trinomials. This method is often called the AC method, as you can probably see why. Anyway, it's a little tricky at first, but the more you practice it, the easier it will get. All right, until next time, have fun.